All right. All right, so I found the problem. I found the problem and I'm ready. The problem is, well, I already described the problem, but now we're going to fix the problem. So, this shorter scalar distance was returning 666, right? And the problem is that if this is never initialized, or maybe, one of these other variables here are not initialized, then we never pick the actual shortest scalar distance because the never initialized variable is equal to 0. Or in our case, I think we might have set it to 666. We set something to 666. Shortest scalar distance set to 666. So what we want to do is we're just going to take this this vector here, and all we got to do to fix our problems is we're going to initialize using a very high float value, right? So we're going to assume the math is with float 32s, and what we're going to do is we're going to do f32, and we're going to go 0x ff, ff, but not ff, right? Because remember, floats are signed, and so they can possibly go negative. So we should do fe, or if we want to be safe, right? These are just single digits from here. So actually, that might not be how it. Yeah, that'll work. So I don't know what the precision is. So let's make absolutely sure. So float 32 max value. Let's look at what the float 32 max value is. So maximum value. So move the decimal place over 3 places. Okay. So let's do GLSL float max value. So how to ensure largest possible float value without, that sounds about right. I don't care about the largest possible, like 1 below, 2 below, 3 below, 4 below, even 5 below, 10 below. Even 10 below, that would be fine. As long as we're as long as we're we're in the, yeah, it doesn't matter if we're a few digits off. GLSLIE, so, okay, so 7, oh god, that's, I get why they would do that, because, there's plenty of times when you can divide by 0, and you don't want to mistakenly divide by 0 and then have your whole shader crash, so I get why they would do this, but, oh boy, I would not do that. Why? Yeah, let's do an erroneous operation to conveniently get a hold of something. That's, oh god, that is dirtier than I would like to be. So, can we actually write it like this? Is that actually legal? 128. Is this, hmm. Int bits to float. That's actually how I would like to do it. Let's see, is that actually a function? A GLSL function? Okay, let's do that. So, ooh. Let's give that a shot. So, we're going to initialize all of the scalar components to the max float, so that way, if we never compute the SZ value, well then SX will definitely be less than that, right? So let's give that a shot. I have no clue if that is a function that will actually work in ShaderToy or not, but let's just give that a shot and see what we can get, because I'm, okay, so no, something, I could have been a syntax error though, because I'm good at just not being able to type code, it seems. Yeah, that would be a problem. So F32. Okay, so let's, you know, now that we've actually, you know, given it proper type, let's try that again. Okay, it went green, and I'm scared to scroll up. Play. No dice? No dice. So this isn't even the, so that is depressing. I'm trying to make sure that we can get back to what we originally had, right? Because originally we didn't have the right results, but we had something. So I at least want to see something, you know. Okay, got it. That was the something, right? Okay. So it definitely does something, that's for sure. Okay, but it's not what we would hope for, is it? Yeah, that's worrisome. Yeah. Alright, well, let's put a breakpoint there, and... let's make sure that the shortest distance isn't all of a sudden somehow... you know, that. So else... if, let's make sure that that isn't happening, right? Instead of or you just do that, whatever, something. Is that almost worse? It is almost worse, isn't it? Great, we're not getting shit now. That's really weird. Like, how? Why? So we should still be getting... somewhere we done fucked up something else. And I don't know what it is. I don't even know what the hell this maroon color is. Isn't that out of bounds color? So let's, oh boy, that's frustrating. Okay. So we're gonna run our color picker. And who the okay, we're gonna run this color picker, and we are gonna select right here, 33000. So I'm pretty sure it's the out of bound color. We're gonna have to find it though, aren't we? Out of bounds, right? This color. So if we add the green in there, right? So we need a way to just take a hex value and convert it to the correct color. And I'm pretty sure we already have a function for that, right? So in this table of errors, don't we use a utility function to take this table of errors and... Oh, wait, no. These aren't the actual hex values, are they? They are... Yes, there we go. So we had a utility function. I knew we did. And the reason we want some type of utility function is we just want to be able to identify a certain color in our output. Like, yeah, I remembered that it was this thing, but you know, a few days or even hours from now, it's not going to be so apparent. So now with this, are we using an alpha channel? Because we might be. Yeah, because the value is going to have an alpha, right? Yep, so there's alpha in here. Okay, so 0x and out of bounds, so it's going to be like a really dark red. I don't know, maybe like 22. Green and blue we'll keep as nothing. Or you could do like 11, 11. And then the alpha channel is FF, right? So you're going to use all of that alpha channel. We could make the alpha channel lowercase, just to... Nah. I'm gonna... That just makes it easier for me to see. So let's take that for out of bound color. I just want to make it so that I can find that again if I... Don't tell me, what's wrong? Oh, because it's not a float 30. It's not a it's not an unsigned integer, right? Is that the problem? God, why does this have to be so hard? Okay. So we'll take that and run with it. And I'm like, I am not happy about the fact that we're not seeing anything now. It's like we fixed more problems as far as I'm concerned, but now we're not seeing shit. Okay, so if we take a color picker on this. And we take a sample of that color, what we're hoping for is that we will see that exact color, that exact hex code. Okay, so color picking 220011. That is exactly what I used. So with that, let's just do some cleanup where we kind of put some absolute colors in places so we know what we're looking at. So inside map bounds, we're going to do like something like this, but a dark green. So we can take this and we can kind of invert it. So we'll do like 1100, maybe 33 instead. Nah, because then they're complementary. I like how they're kind of complementary. right? These two values. So I will take that, and let's just run. Well, it doesn't matter, right? Because we're not gonna see that, are we? Okay, so we did a little bit of cleanup, and now we're pissed because it's like it's not working. I thought we fixed this. I thought we looked at everything that was wrong. I thought, you know. Are we no longer dollying? So if we look for that bug value, are we still using the bug value to like go up and down and you know whatnot? So if we look at bug, BUG, we're using this positive coast value. Let's try, I don't know, let's try neg coast. I don't know. I at least want to see those cross sections again, right? And now that we're not seeing anything, it's like what? Why are we not seeing anything? Yeah, that's just fucking great. Okay, so let's what we're gonna do is we're gonna take. Well, first of all, let's go back to where a problem is, right? And let's just use the correct ray marching for. Right, we decided that that's the way we want to do this. And oh, right, yeah, let's try, I know when we tampered with this, we ended up with some problems. Let's do divided by 2.0 really quick. Okay, so we're just in trouble, aren't we? Okay, so now we're back somewhere. Okay, so we're back somewhere. We're still, like, not in a good place. And also, that's not the color I wanted, is it? So, we want this color to be something. So, let's do 0, 0, and we'll put the 2, 2, like, right there, right? We want kind of like a darkish green, right? And we are, we got these colors wrong. So let's flip that around. Okay, man, I just suck at this today. Let's do 3, 3. So outside of map bounds, we're going to be at a very intense red, well, not an intense red, but a dark red, and this will be a dark green, right? And we're kind of like muting it, but let's not mute it. Let's mute it a bit just so that we can tell the difference between where all the bytes are. Okay, so let's take that and make sure that our colors are the colors we think they should be. Okay, so outside of the bounds is kind of this maroonish color. Inside the bounds is this greenish color. And we're still not seeing anything there. Okay. So... we just, if we get rid of this, right, we're not going to see anything, right? So the distance... is the distance somehow... just like the distance on, like, the X? Yeah, not the correct normalized distance? Could that be what's going on here? So let's go look at this again. Let's see what other stupid things we may have done. Okay, wait. Yeah. Okay, yeah. We're taking the component SX, XY, SZ. That's a scalar quantity being applied to a vector. Because we are solving with point normal form using just one, right, we're individually, when we find the collision, we're just using one of them, one component of these, SX, maybe that's not it, SY, and SZ. So we're returning SX, returning SY, returning SZ. Okay. Is that not correct? Is my math wrong? Okay, so it seems like we have the math right? So we want to figure out what bound we're checking for, right? So if the normal on the x is positive, then we're going to use the upper bound. Otherwise, we're going to use that lower bound. And we're going to take the current tile x, and we're going to just multiply by the number of pixels in a tile, right? And this the current tile plus 1, right? And that'll give us this is the first set of pixels in the next voxel over. These are the last pixels of the voxel previous. And for which bounds we're checking, if the bound we're trying to collide with is this. I'm going to just have to draw some of this out and see if some of my reasoning is wrong or something. So, okay, so we use point normal form and to figure out where we're going to collide with we use point normal form to kind of figure out where the oh wait, oh hold on. Nope, okay, that makes sense. So we use point normal form to figure out how far to scale along the vector to hit different boundaries, right? An x-plane, a y-plane, and a z-plane. And these boundaries, they look sensible to me. And the point normal form makes sense to me. So we do point plus normal times scalar equals the first pixel of the next voxel. Right, but in a vec3 here. Isolate a component, so we'll try to solve for the, the x intersection. Bx minus px. Right, so we're going to minus px. Then from here, we got to divide the nx out. So bx minus px divided by nx. And we have bx minus px divided by nx here. That is if nx is not equal to exactly 0. If it's equal to exactly 0, we give up on it, right? Otherwise, we'll set it. And we even gave it this trap value. Maybe this weirdness that we're trying isn't exactly right. Maybe let's just try 0x 7F, 7F. So, let's see. The endianness could be affecting what this is. So giving it... Okay, so this might be a bad idea. Let's try... Let's give that a shot. I don't think it'll fix it, but, you know, let's give it a shot, see what happens. Because, I mean, that's the kind of like the thing we're kind of like tampering with, that... No. Well, let's set it to something really big. So, let's set it to something large, but something that we can comprehend. So, we just set it to like, 1,000 times 1,000. That should be big enough for our purposes, for what we're doing, and it's something we can wrap our head around, and we can kind of like use these other more tricky things after we've kind of like done a sanity check and made sure that that's not a problem in our code, right? Okay, so we're still getting the lack of proper array marching, right? So, if we get rid of this division, it looks like it's jumping too far, right? Because we get rid of that division, oh, hey, what's up with that? Okay, so somewhere in our infinite wisdom, because we thought we were smart or something. Well, I mean, if we divide... so that's just weird that, so it's like going too far almost. Like, well, maybe we have some type of infinite infinity. It may be dividing that by 4. So can we check for infinity? Oh, first of all, where the fuck? Oh, less than or equal to 0. Okay, so we do have that. Check for infinity, right? So check for infinity GLSL. So what if is inf, right? Like maybe where okay, so we're just going to throw something else in here just in case. So else, if is inf dn, right? Just in case, because if it's infinity, we're going to, let's start doing the proper thing here and start trying to use like exact hex colors. So if it's infinity, we're gonna make it like E1, 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 or E0. Yeah, so something like that's really close to white, because I'm thinking like, you know, infinity, going towards the light. I don't know. Let's try that and see if maybe we're gonna end up with like a white screen, right? Maybe, you know, we fixed one bug and we ended up with another, maybe? Nope, so it still just thinks we're out of bounds. Yeah, okay, so I don't know what's going on, and so we're out of bounds, but is there any way to get a reading of how far out of bounds we are? Like, how far away from the original array are we? Right? I think that would be helpful if we had some type of feedback like that. Like, okay, we're out of bounds, but how far away are we? So, like, so outside of map bounds, like, let's take this here, and let's attempt, well, before we do this, let's just go back to dividing by 4.0, just so that we have some feedback, right? So that we can actually see something, so that we don't feel like completely demoralized, because that's kind of demoralizing not seeing anything. And so at least we have a hunch for where things are wrong, right? That division by 4 gives us a hunch of where things are wrong. It kind of tells us that dn must not be 0, just because when we divide by 4, all of a sudden things are working. So something about, I have no clue why. It almost seems like it only does like one, yeah, I don't know. So what we're gonna do is we're gonna try to get some more feedback here by seeing how far away from the original, how far we've kind of journeyed. So this ray world coordinate and the XYZ, we can take the delta of that, and we have max steps, but we don't really have a max distance, do we? So we're gonna do a float 32. Float 32. Total distance from RWC. So XYZ total distance from RWC, right? Equals, right? So they start out the same, right? So XYZ equals RWC means that this is exactly what it is to begin with. And we want to try to shade this this area based on how far away we are. We want to like get some type of feedback as to like how far are these rays marching, right? And hopefully that'll give us some type of feedback to where we can kind of figure things out. So total distance from RWC. Okay, so and to calculate that, right? We don't really need to put it there, do we? Out of bounds. So we can say that this equals the len length XYZ minus RWC, right? And then we need like a max distance. Oh, that's why I wanted this. So we need the max. We need a max distance bailout here. So we want to take the distance of where we currently are. This is going to get the current voxel we're in. And dist next is going to be where we are later. So we're going to take this and plus equals dn, right? Distance next. Right, so this is before here. This gets distance next. But we're going to do this before because this starts out at 0, right? So the current this will get the current voxel we're in, and the distance from ray world coordinate for the first voxel is 0. So this is before this function. Just to make note of that. I'll use B4 because I don't have room. Okay, so with that, if it's too far away, we just don't render it, right? We just break out, right? We do have a max distance. Have we even used it yet? 1000 is probably not a good value. Because our tile map is, well, let's take like 64 times 16, 1024. And let's give it like 3 times on each side, right? Yeah, let's give it 3 times that on each side. Let's do 1024. Well, let's actually keep the actual calculation. So 64 times 16 times 3, right? Okay, so that's a bit more of a max distance. I think that's more acceptable for what we're trying to do. We also have to put these point zeros here, or else it's not going to work. Okay, so max distance. Okay. And if that is the case, and then we can kind of play with trying to get some type of gradient here, right? But let's make sure this actually all compiles, because we probably made a mistake somewhere, so let's just run this and see what we did wrong. Or I guess it worked, so that's cool. So we're going to take C4... We're gonna take we're gonna take a we're gonna take a vec3 that's just all ones multiplied by 1.0 or multiplied by some type of fraction. This F32 percent away equals okay, we cannot fuck this long variable name. Let's rename it to something else. We can keep a comment maybe like over here about it, but this is not, this is no, I hate this. XYZ total distance from RWC, right? That's better. So find next, replace, don't replace that one, replace. Okay. Okay, now we can look at some of this, and this ugly shit over here, we can kind of clean that up a little bit. It's still a little bit too dense. Percent equals, this is the current value over the max dis, right? So the current value divided by the furthest away you can be. Okay, and you have to remember that the further away should not be like should not be an intense value, right? Further away should probably be like a darker value. So we'll call this F32 inverted equals 1.0 minus the percentage. And then we'll take this multiply it by the per, and then we'll put ovec4 in the constructor, alpha channel 1.0. Okay. So now I'm expecting to, and I can, we can comment this one out. So color 4D is going to be like this gradation, right? And we're expecting to kind of get some information about like how we're ray marching by giving this like gradation information. And seeing like, well, is it consistent? Is it... Okay, well that's actually helpful. So if we... Oh, and we're supposed to multiply by inverted. Save that. So inverted. So the total distance away, if this is a very small distance, then it's 1 over a big number. So a very small fraction. So the percentage is very close to 0. But when we're very close to 0, we want to keep it white because we're close, right? We haven't gone into the darkness, kind of a thing. So we're going to invert it. And if we invert... Okay, so let's take that and see what we get. So I'm expecting kind of a white now, because I used the wrong variable there. Okay, so now we got this white. Okay, so that's actually kind of some good information, because we know that it looks like we're not going anywhere, you know? Let's just multiply that by 1.0, and so let's just make the range a little bit smaller for that max distance. Make sure that we're still rendering what is already there, but maybe we can get some type of gradation going, or maybe we can't, but let's just see. No dice. Huh, wait, what's that? Oh, no, okay. So, but that's some information now. With that, and it's all white. It's basically saying that we have done one little march, and then we gave up, is what that kind of means, right? And so now the question is, well, why is it just giving up? And we got to figure that out. So this value here, value is the value of the voxel, and let's okay, so let's take this. Hold on. So this sucks, is what this is. But we see that it's white, so it's not ray marching. It's not going anywhere. Well, I mean, this value is really small, you know, so maybe that's a problem. You know, maybe we want to just keep it like that, but then I know it didn't go anywhere. But let's just change some things around and see if maybe do we just go from white to black? How the hell do we go from white to black? How is it that dividing by 4.0 makes it go from white to black? Okay, so once again, thinking that it's infinity. Maybe it's not infinity, but it's damn near close, I bet. How is that? How is it that Okay, let's divide by 2. So the difference between dividing by 4 and not dividing is like the difference between gradating off into infinity and... Okay, so there's a gray. Okay, so... If you take smaller steps, we hit the max step sooner, right? We hit the max step sooner, and we don't get as far as away, right? That makes sense. So this max step here, if we take smaller steps, we hit max step sooner, and we just never collide. Or... Okay, so that makes sense that we don't get as far away. 2.0. Wait, no, that doesn't make sense. Well, we're taking a smaller step, so we're not getting as far away. No, okay. Which means it's brighter, because we haven't gotten further away. Okay. But that stark contrast is kind of like, why such a stark contrast? Oh, wait, the top of the model is, the top of the model here is... Where are you? The orange. And... I don't understand why the hell... It's not ray marching. I think it's taking one step and... Well, no, because it takes max steps. It goes to max steps. Okay, so one thing we could do is... You know, if we made the tile map larger, actually, we could get some more information here. You know, we could get some more feedback. So let's... So why not? Why not make the map a little bit bigger, right? So if we go over to where we kind of like created that tile map data, let's make it a little bit bigger. Let's add some more layers. And right now we have 3 layers, so X, Y, and Z. Let's just say, let's just add some more layers, right? So let's just get, I don't know, doesn't really matter how many. God damn it. And everything's freezing on me. So let's close some tabs. And space this here. Or let's not. Let's close our shortcut file because I know that takes up a lot of room. What the hell? Okay. Need more RAM, obviously. so we're gonna add 1, 2, 3. Okay, and we need Is this just my life here? What the fucking hell? I'm gonna close ShaderToy. I think maybe ShaderToy is doing it. I could be wrong. Maybe ShaderToy is not the offender, but far too often it's ShaderToy that does it to me. So we're gonna leave. We're gonna close. We're gonna close Torch browser, and yeah, it looks like Torch browser might have been our offender. Well, maybe not. Okay, so let's see if... Okay, so let's take this and let's just put some commas over here. And then once we have it running, we will worry about getting it working again. So we'll just put some underscores. Yeah, that feels like it might be running a little bit better. For this last one, no comma last element. And let's just let's blank some stuff out. Let's just make something like we don't really have enough room to... We don't have enough. We don't have enough stuff to even make the number 3, do we? So let's let's take all the colors. Let's just kind of animate them, right? Let's just do a little hackish kind of animation where they're like moving all the way down here, right? And 1, 2, 3, 4. So we've added 4 new levels. 1, 2, 3, 4, 5, 6, 7. Okay, we're at 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so we'll add a 7 here to the end. And NTZ needs to be a 7 here now. NTZ is a 7, NTX is an 8, NTY is a 4. So let's give that a shot and hope we haven't like completely blown everything up. So we just want to like see if we can try to like, you know, I don't know, see something else. See some other feedback. We're just guessing around by now, but let's just try to let's take this and we'll recompile that. Hope we haven't made any horrible mistakes. And let's look at this and see what we got. Oh, here we go. So you can still see the same stuff. I don't think it goes down far enough the camera slice plane doesn't go down far enough to like see. That's the thing. It's still functioning. It still seems to be functioning as a slice plane rather than a can we save this? Can we hit save? Just save what we have currently. And yeah, so it's still functioning as a slice plane. It's not. There's nothing here that's telling me that it is. As the camera's moving, it's not. The problem could be that it's not going through the green tiles. That the green tiles. I know that we said that the green tiles were not special tiles, right? So that's still a consideration, right? So maybe that's all. That could be the only thing we're screwing up right now. Is that the tiles, if they're inside the bounds, they're still considered tiles. But okay, well, even if that's the case, if we get rid of that 4.0, right, we're not going to see anything, right? And so there's still some other type of problem, even if that will like alleviate some of the problem. That's still not completely solving everything, right? So that's still a problem, right? It's somehow this step, this distance to the next tile is it's too large. It's definitely too large. I don't know why it's too large. And if we times it by 0.999, right? Like what order of magnitude too large is it, right? Is it like why is it? I know we divided by 4, so 0.5 0.4 divided by 4 would be like 0.25. But I just want to change it around and kind of like see if I can get in. Okay, so let's we can kind of see it changing, the hue changing a bit, right? Because the plane is moving back and forth, but okay, so I have no clue why this distance is too large. So let's make it this distance dn is too large for some reason. Okay, so dn is too large for some reason. Okay, well, how are we calculating okay, yeah, so we would stop. Hold up. Well, if we're inside the map bounds, there's nothing telling us that we're going to exit. So eventually we're trying to get into here. So that's not really the problem. Well, I don't know what the problem is right now. Yeah, I don't know. Why the hell? Okay, why is our distance, like, a lot larger than it should be, right? Um... Yeah, I don't know. I don't know. I don't know. Don't fucking know, man. It seems like my math is wrong here. Like, this function is still like something I've never done before, and so I just feel like, What if we're in a negative tile? We would be, if we're way up here, if the camera's way up here, we're in a negative tile. And if we are in a negative tile, how is that going to affect this math? Oh. Uh-huh. Well, if we're in a negative tile, so -1. So I want to find the next pixel ahead. Well, if this was -1, +1, that's a 0 times the number of pixels x. Then we're still going to get something. Okay, but what if the tile value is -2, right? Then we get a -1. And -1 times number of pixels x will give us like these negative pixel values that should still be in the correct spot, right? So that should still, however, if that's the case, the tile in front of us, and this is still the yeah, I mean, that still seems like it would make sense even with the tile x value being negative. That still seems like it would make sense. It still seems like it would work. So let's take this, let's paste it, let's make sure that we still have what we think we have. And I'm gonna take a break, and I'm gonna do like a third session here. I'm gonna try to get some food and then just think. I don't know what's going on. So I'll be back later.